Welcome all. Now I am going to discuss question number 52 from the GATE 2020 paper Electrical Engineering. The question is, a non-ideal silicon biased PN junction diode is tested by sweeping the bias applied across its terminals from minus 5 volts to plus 5 volts. The effective thermal voltage Vt for the diode is measured to be 29 plus or minus 2 millivolts. The resolution of the voltage source in the measurement range is 1 millivolts. The percentage uncertainty round off to 2 decimal places in the measured current at a bias voltage of 0.02 volts is. To know the calculations of the percentage uncertainty, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. For any measurement, there will be some percentage of uncertainty in the readings. So, those are not accurate or wrong. So, it is generally calculated by using the partial derivative of the expression with respect to the dependent variables. For example, mx plus ny. So, this measurement depends on x and y values. So, the percentage uncertainty is m into derivative of this expression with respect to x whole square plus n into this derivative with respect to y whole square. So, using this information, let us solve the problem. Let us solve the problem. Given data, given it is the bias voltage range. Bias voltage range is minus 5 volts to plus 5 volts. And the thermal voltage for the diode. Thermal voltage, we represent bias voltage as VB, thermal voltage as VT. 29 plus or minus 2 millivolts. And also the resolution of the voltage source is 1 millivolts. Resolution of the voltage source is 1 millivolts. So, the percentage of uncertainty in the measured current we need to find at the bias voltage is, when the bias voltage is 0.02 volts. Bias voltage we represent it with Vd. So, we should know that current flow through the diode, that is Id is equal to Is into source current e to the power of minus Vd by neta Vt. Here Vt is thermal voltage. Vt is thermal voltage. Neta is the constant for silicon. And Vd is the bias voltage. And just now we had discussed with the percentage of uncertainty with respect to the diode current. That is, here diode current is depending on the bias voltage and the thermal voltage. So, we need to take partial derivatives with respect to bias voltage and thermal voltage. That is, dou Id by dou Vd whole square into standard deviation of the Vd square plus dou Id by another dependent variable is Vt, dou Vt whole square into delta sigma Vt square. So we should calculate the partial derivatives. Dou Id by dou Vd is equal to Is into e to the power of minus Vd by neta Vt into minus 1 by neta Vt. So we can write whole this expression as Id, right, is equal to Id minus Id by neta Vt. This is the partial derivative of the diode current with respect to the bias voltage. Similarly, we need to calculate the partial derivative of the diode current with respect to the thermal voltage. That is Is into e to the power of minus Vd by neta Vt into minus Vd divided by neta into Vt square minus Vt square. So this expression is again Id, right? So Id into Vd divided by neta into Vt square. This expression is the diode current with respect to the thermal voltage. So we will substitute these two expressions in the percentage of uncertainty calculation. That is sigma Tb is equal to root over dou Id by dou Vd into sigma Vd square plus dou Id by dou Vt into sigma Vt square, which is equal to dou Id by dou Vd is Id by neta Vt. Id by neta Vt into sigma Vd square plus dou Id by dou Vt is Id into Vd divided by neta Vt square whole square into sigma Vt square. So percentage of uncertainty is sigma Tb by Ib into 100, that is equal to root over Id square and square root. So we can take Id. So we have divided that Id with this sigma Tb. So 1 by neta Vt whole square into sigma Vd square plus Vd square divided by neta square into Vt to the power of 4 into sigma into Vt square. So we need to substitute the values. Sigma Tb by Id into 100 is equal to sigma Vd is 1 into 10 to the power of minus 3 whole square divided by neta square is 2 square into Vt is 29 millivolts, 10 to the power of minus 3 whole square plus Vd square is how much? Bias voltage is 0.02 whole square into sigma Vt is 2 into 10 to the power of minus 3 whole square divided by neta square is 2 square into Vt to the power of 4, 29 into 10 to the power of minus 3 to the power of 4. This is equal to square root of 0.0002972 plus 0.002262, that is equal to 0.05058 into 100. This is percentage, right? So that is 5.058 percentage. So this much of uncertainty is there. So the percentage of uncertainty in the measured current is 5.058. Thank you.